I'm Charlotte. I'm the founder at Captur. I have about 12 years of experience in supply chain logistics and 8 years of experience in specifically helping enterprise companies, so e-com retailers and delivery companies, implement AI. So specialist in the space when it comes to running enterprise AI projects. And then we've got Philip joining us from our team. Go ahead, say hi.
Yes, hi, I'm Philip. I'm the senior machine learning engineer at Captur. So I'm responsible for making sure that the models do what they're supposed to do, but also the engineering side. Before that, I was a research scientist at Onfido, so it was more like digital identity verification. And I've done like a few things at different startups over the last 8 or 9 years, so quite a bit of a variety of machine learning experience there.
You have a favorite model at the moment? What's your favorite foundation model?
Ooh, favorite model. That's a good question. I keep on going back from Claude and ChatGPT, but it's hard. It's hard. I like the open source initiatives a bit more these days. I'm a big fan of open source myself. So.
If anyone has a favorite model, drop it in the chat. We can go for it. So we will start getting into the content, I think. And again, if you've just joined, there's a poll and quiz. You can let us know where you are at specifically with your AI roadmap. We only have 30 minutes. We're going to keep it really quick and really informative. You're also going to have access to the resources after this webinar, so don't worry. We're going to do a quick intro on why AI road mapping is hard, walk through a template AI roadmap, a live walkthrough of 2 examples, and then we're going to finish off with giving you some pro tips on like how to set up an AI project for success. Great. So what we know about road mapping. So this is just a sample roadmap. It'll look pretty familiar probably. You've got a bunch of different initiatives, a bunch of different company objectives, and there's some sort of kind of baseline target numbers that you're trying to hit. So this is what we know about road mapping. So initiatives, targets, and results, right? It's all pretty straightforward. Why is this harder for AI projects? Well, who knows what the target should be, right? It's really hard to quantify that. And if you can't quantify the target, then what should the results be? Right. So this is why it is hard, and many people in the market struggle with setting the correct kind of framework for AI projects. And if we can't set targets, then we can't measure results. And then our roadmap looks something like AI Jenga, which is kind of hoping that everything's going to go okay, but not really being sure of if you're measuring the right thing. So that's what we want to avoid, and hope you guys stay on the right track. Now, what Philip and I are going to walk through now over the next kind of 15 minutes, 20 minutes or so, is specifically an AI roadmap that we developed and built to help teams go through the whole process. We are not going to go through the entire road mapping process, so we are going to be starting at step 4. We're going to assume in this roadmap session that everyone has already gone through, or maybe you are about to go through, setting the first 3 questions. So what could we work on? What should we work on? What should we do first? And then where we're going to come in is, well, how do we know? Like, how do we measure it? When will the AI be good enough? Obviously, the first bit is your company strategy. The second question, what should we work on, is your product strategy. And then what should we do first is more of a feature list and allocation. So we're going to go into the AI road mapping template. Now, you're going to have a link to the chat in here, into this template. So you can dive into the sheet and follow on directly if you want. What you're going to see in this sheet is we've got an instruction page, and this takes you through all 4 steps. So if you're starting from step 1, you can still use this template, which goes through steps 1 through 3. And as I said, where we are today in terms of making the most out of this road mapping session is we're going to assume that you've narrowed down your long list of AI initiatives to a few that we want to focus on. So we've got 2 examples to work through of potential AI projects that might be on your roadmap. And for anyone who's just joining, you've joined at the perfect time. We're just starting the hands-on session, walking through an example of how to roadmap and kind of scope AI initiatives and projects. Let us know with a Q&A, kind of poll question here, where you're at specifically with your road mapping. Okay, so we've got a list of AI initiatives. We could have 50 here, but we've already scoped down in terms of what's important to the company, a short list. The two examples that we have, so we're going to start with the first one. The first one is thinking about, could we add AI to our customer chat, to our customer support? And maybe we want this chat to be like a first triage, a line of defense for claims when the customer says, "Where is my order?" And so if someone submits a "Where is my order" claim, we think that we can get some AI to reply to that. And in doing so, we can reduce initial response time. We want to reduce initial response time because we know when a customer is submitting a missing order claim, they're already pretty angry. They haven't gotten their item. So we want to respond quickly. So that might be an initiative, right, on your roadmap for next year. Can we add an AI chat support? So how should we think about scoping this initiative? So other than the things that, again, we've already assumed you've gone through an exercise with your team, which goes through kind of what's the ease and the value of this initiative. In terms of how to scope the AI, so there are a couple things to think through. So one of the key areas to think through in terms of the AI projects initiatives is, what's the cost of the AI getting it wrong? And so cost we can think about in three ways: time, money, and user experience. On this template, what it allows you to do is quickly go through and triage to say, okay, what matters most here? So if I'm going to embed an AI chatbot, right, for missing order claims, there's a potential UX risk, right? Because if I get it wrong, the customer might be even more angry. And there's potential dollar risk too. If we get it wrong, maybe we're liable for the claim. Now, in this section, what you can do is input in, how much weight you give to those different things. So you could change the weighting here and, flip these numbers around, but we'll keep it as is. And the second thing to consider when we're trying to scope out, how good does the AI need to be to go live with one of these projects, is what sort of level of oversight you expect there to be with AI. So we've broken it down into three general levels of oversight. One, there's a human in the loop. So there's going to be someone checking every result, right? This acts like a co-pilot. Two, is it a spot check? So is someone going to be auditing? It's still a manual audit, but it's periodic. It's not on every one. Or is there no level of oversight, as in you need the system to run completely autonomously? So if we're going to have an AI chatbot responding to customers, you might say we need to have a human in the loop, for all of the answers to start. Or you might say, hey, we actually want to do a spot check, or maybe you're looking for actually no oversight at all. You can see when I'm changing the responses here, we've got a cost of mistake and level of oversight needed, and these are ranked in terms of low, medium, and high. Okay. Is there anything else you'd consider, Philip, when you be setting up a project like this? Integrating LLM, potentially multimodal inputs.
Yeah, I think a very big thing is also the probability of success. Like, how much research do you need to make it work? Are you certain it's going to work? Yes or no? Basically, the technological risk is one of the big ones, which is also extremely hard to estimate, right? Because it's a research project in that sense. So that's a big thing.
Yeah, definitely. Even before you get to this point. And for this example, if you want to integrate chat into your customer support tool, the cost of mistake, this will obviously depend on your business. So that's why you guys have access to the template and you can play around with this. But the cost of the mistake is relatively high, right? There's a user experience impact, there's a monetary impact. And the level of oversight you're going to have, maybe if it's high, if there's going to be a human in the loop, or maybe it will say it's just going to be a spot check. So in terms of how you can read this chart now, the output here is kind of a good enough range, kind of a very much indicative range, but at least something to get you started on how good would the AI need to be in order to go live with that. Now, what's really important too is thinking about how are you actually going to measure, these ranges? And so we're going to go into that in a little bit. But something really important to think about and to define from the very earliest stages of a project is what is right. So what is a positive prediction or positive output for the AI? So for example, if an order is not delivered, someone submits a missing order claim, maybe the AI is right when it helps the customer as quickly as possible. So maybe we're looking to optimize speed and we're going to accept a couple like wrong answers. Right? Or do you really care about being highly precise, highly right the whole time? But this gives you like a kind of accuracy range. Now, these ranges are based on, what our team has measured in terms of manual benchmarks, so kind of how good humans are at certain tasks today. They're also based on what we know of, how good some foundation models can be in the industry. So again, they're indicative, but they give you at least a starting place. And the first thing that you should do with any AI project is to actually try and measure yourself. Well, what is the baseline of how good, if a human is doing this task today, how good are they at doing that? The second example that we've got is not purely chat, but it's actually looking more at image-based computer vision data. And so let's say you are a delivery company and you've got riders sharing vehicles pre and post shift, and you want to do a post shift check and use AI to scan to detect if there's any new damage on the vehicle. So let's talk through this one, Philip, in terms of cost of the AI getting it wrong here. Probably we're talking more about time, like if damage is missed, it's going to be time spent going back and forth on a damage claim. It's also potentially costly. There's going to be damage that's not spotted that we have to pay for later on. User experience is probably less of an impact here because the person's going to be doing a check, a scan anyway, and maybe we're not giving them immediate feedback. So I think the main ones there are time and cost in terms of money. And let's say we want to have someone doing a spot check on this. So maybe an ops team member is checking every 100,000 inspections. In that case,
another option would also be, I think, especially in these kinds of cases, is that you do the spot check when there's damage, right? With the high risk prediction. You always send it to the human, especially at the first stages, and then maybe just a random spot check for the other ones. Yeah, these kinds of things are usually to think about.
Yeah, definitely. That's a good point. So it's actually one where you're suggesting you could actually stage in or change the level of oversight.
Exactly. Yeah.
Needed in the project. Yeah. So in this case, if you look at this kind of medium high ranking, so the cost of the mistake is maybe a medium. That could depend on your business, obviously. And the level of oversight, if you start with a high level of oversight, maybe you actually don't need such high precision to start with. If there's oversight, you can get away with a range of about 80%. But if there's going to be just a periodic spot check, it's higher. If you want this to be a completely autonomous system, then it needs to be even higher still. So just like you said, Philip, these don't need to be binary things. This can be, how you change your oversight over time, and getting started with a project, you might want to have a higher level of human in the loop impact. How would you think about these numbers and for these two cases in terms of precision and recall?
Yeah,
what is
that's a really
accuracy here? Yeah.
Yeah, that's a fairly business dependent use case, right? Accuracy can be anything that's important for your business. It's not a single well-defined metric. It really depends on your business use case. Precision recall, similarly, right? For the same problem, for one business, the precision can be important, while for the other business, the recall can be important. These things can even change over time if regulations change, etc. I think, yeah, ideally you would give a really nice, simple answer for people to use, but it's all going to be very dependent on your own business use case and the economics of your predictions and what you care about.
Yeah, definitely. And if let's just check in. We can probably do one more example as well if anyone has an AI project in the chat. Let's check in on that one. So if you're working through an AI initiative, so we can work through the example now, or we can actually do that with your team afterwards. So you just let us know. So to recap, what are we doing here, right? So we've already gone through an exercise. We're assuming you've gone through an exercise with your team on here are all the different things AI could do, we could do with AI. You've been able to prioritize that a bit based on your company strategy. Maybe you've gotten to the point where you want to start to scope out the level of difficulty. How long will this project take? How will we know when the AI is good enough to go live? And so that's what we're introducing here with this framework or this template to help your teams at least start to set some of those, what we had here, right? Some of those guidelines, some of those targets, right? In order to be able to measure and roadmap properly. And the most important thing when we're doing this is to remember that, these are ranges and these numbers are going to be very much dependent on how you set up the measurement of accuracy. And it's really important to always come back to the end user experience, right? So if you step back and look, outside of the numbers, you can think quite logically about some of these examples, right? So a chatbot to reply back, to a customer if they've submitted a missing order claim. Well, you might think, well, how quick is a human today? How are they able to do that in a split second? Well, it might depend. Like, what sort of information are they trying to gather? Or is it is it a difficult decision? Is it an easy decision? And try and benchmark like how accurate do you think people would be at that task today? And when you're talking about something like spotting damage, right, on vehicles, the next step of this scoping would be to actually narrow it down much further to say, well, is there one specific most important type of damage that you'd want to actually start with and scope it in? There's some it can be complicated, but they should be, hopefully we're going to expose and make them easier, some terminology when it comes to AI accuracy that you really should know and understand, especially working with your engineering teams. You want to be able to prod them on this. So now that you have an idea of how to, what AI initiatives you want to do, and then you can use this template to give you indicative ranges of relatively, is it a low, medium, high cost of mistake of the AI getting it wrong? And do we require low, medium, or high level of oversight? Now you can think about, okay, what else is most important to us? And so when we speak about accuracy, there are two things to consider. And I think, Philip, you can take the team through these ones. But it really comes down to, do you care about being very precise, or do you care about catching all the scenarios, right?
Yeah, exactly. So maybe it's good if you go back to the last slide. So I want to talk a little bit about, okay, now you have your project set up, you're quite sure that you're going to do this. How do you define what you're measuring from like a machine learning model point of view? So I think that the first step, which is quite often overlooked actually, is what Charlotte already talked about, is about like defining this positive class. So let's imagine the case where you have a binary classification. So that means you basically get one of two outputs out of it. So what we do at Captur is, for instance, you are parking your micro mobility vehicle, so an e-bike or an e-scooter, and we have to predict, is it good or bad parking? So two decisions. Similarly, you have is a vehicle damaged, yes or no? So the first thing you have to do is like defining this positive class. And one guideline I would say is, okay, what is the key business target here that you're interested in? So if you have a lot of problems with city regulations, you want to be really targeting bad parking. So that would be your positive class. If you really want to find all the damage, then obviously your positive class will be damage detection. And we'll see in the next slide why this is actually really important to get right. So after you've had this positive class, you have to start a little bit about what kind of behavior do you want your model to exposed to. So there are a few knobs you can tune basically to have the model do whatever you want. So precision recall is usually a trade-off that is quite important to understand. There are obviously many more metrics, but I think it's good to have a bit of an understanding of these two metrics. So precision is basically how precise is your model about predicting this positive clause. So it's a bit in the name, right? So anytime we predict bad parking, for instance, or there's a damage on this vehicle, how confident are we that this prediction is actually correct? So you can also see this as we're being quite conservative by predicting the correct positive case. On the other hand, we have recall, where this is, for instance, really important in the medical field if you're trying to find the presence of a particular disease. So anytime something happens, like the positive case happens in the real world, so for instance, the disease is present or bad parking is present, you want to make sure that your model predicts this. The other side of this coin is obviously that you're now a bit less conservative with your positive predictions. So you're also going to punish, for instance, good parking users or users that don't have this disease. So you have a bit of a balance between either being very precise or catching everything that is there. And usually, this is a spectrum of two things, right? You're not optimizing just for precision or just for recall. You're trying to find a balance point. So what usually happens is I want to only punish, let's say, 5% of the good users while catching as many of the bad users as possible. So this is also why it's really important to define this positive clause correctly, right? Because if you get this wrong, the precision and recall metrics and ideas that you read about online just stop making sense. So it's really important to get this right.
And so this would be an example of the positive prediction.
Yes, exactly.
The positive clause, yeah. So here, for example, for the AI chatbot that you want to implement, is it? Do you think it's worse if the chatbot gets something wrong, or is it worse if they fail to send a response? With damage, is it worse if you miss some damage, or is it worse if you maybe don't pick up a little signal that possibly could be damaged? So like Philip said, it's that trade-off and precision. When you think about precision, do you care about avoiding incorrect responses versus do you care about ensuring the AI doesn't miss any positive cases? So in the case that he was alluding to, that simple good and bad parking, is it worse to say this bad parking is good and potentially give some, add some user friction? Or is it worse to say the good parking is bad, but the user can still end their trip? You can think of this in terms of delivery as well. If you have a photo of a delivery package, is it worse to tell a delivery driver who's delivered something perfectly that actually they've done a bad job and adding time to the delivery? Or is it worse to miss a couple cases, right, when they haven't done a good job?
Yeah, and I think it's important to understand that there's not necessarily a right answer. You have to make some hard decisions, and it's a dynamic thing as well, right? So if you see, for instance, this bad parking image, it's blocking the pavement of the blind people, which certain councils might get way more aggressive over time of correcting this kind of behavior, right? So you have to be able to change when your data is changing or regulations are changing. So it's not a fixed answer. It changes over time.
Definitely.
All right, yeah.
Great.
So a few tips on actually how do you gradually roll out machine learning models and validate if models are working in production, while mostly minimizing risk of things going wrong. So a few things that I've seen working well in practice during different stages of the project. So I think before you start, it's really important to define these goals early on, like precision recall, trade-offs, what is the positive clause, or any other metrics that you want to target. There probably are going to be wrong, and you will update them over time. But I think it's at least good to have them before you start, instead of just seeing where it ends. That's the first thing. The second one is, which Charlotte already alluded to, like measure the benchmark of how good humans or current processes are. So if you're trying to perform a task with AI, measure how it's currently going. And also, I think that gives you a really good insight into where to set these initial early goals as well. So you have a bit of an idea of where how hard the task is as well. Then if you have a system where you're quite happy in the offline evaluation, so like let's say in the research sandbox, your engineers or data science are coming back with some good initial results, then there are two things I think you can do to be a bit more confident before you're actually releasing it to end users. So you can have a ghost mode production system. So you basically deploy the machine learning model or the AI in production, but you're not returning any of the responses back to the user. So it's basically just running alongside the actual traffic, but you're then can use this to analyze how it would be doing. Secondly, you send a bunch of this data that you're now gathering during your fake production traffic, basically, to either yourself, you're going to label it yourself, or you're sending it to labelers externally. And I think personally, it's really important to send data to multiple labelers at the same time, because tasks are harder than you think. The real world is really messy. There are a lot of edge cases. And it's just very useful, especially at the start of the project, to make sure that your labeling and your analysis is super clean. So only when labelers are agreeing over tasks, that's when you use this for analysis. And then after you're quite happy with that, I think it's extremely important to just start with predicting the least amount of risky things in production first. So most machine learning systems are a bit of a hierarchical system of different stages of predictions. In our case, for instance, if we think about parking compliance, we first have to see if there's a bike in the image or like the parking bay visible before we can actually make a decision if something is good or bad. So first start with the easy thing, like, is there a bike, yes or no? You start to understand the problem better. You have less risk, especially if this is the first time you're using machine learning or AI, you can understand and optimize your like engineering pipelines as well. And then when you're quite confident with that, you can roll out more advanced and like risky predictions in some sense. Last but not least, I would say always check the data and predictions yourself. I've seen a lot of times where people deploy machine learning models and then have a dashboard with, let's say, 4 or 5 statistics. And it's like there's a lot of very, very useful information that can be hidden if you just look at a single aggregate statistic. So look at like things that your model is getting wrong, where the model is uncertain. Just get your hands dirty if you're an engineer or product manager, because it's really hard to get a good intuition of how the model is performing if you never have a look at the data. So these are a few tips that I've seen working well when you're rolling out machine learning in the real world. Just never underestimate how messy the real world is, I would say.
Love that. Thank you, guys. Thanks, everyone. We've got a minute left, so we're going to end on time. And hope everyone has good road mapping sessions for 2025 coming up over the next week. We'll share these resources. Again, if you've got any follow-up questions, Philip and I are happy to take them. Happy to help you in communicating with your teams, how to think through some of these metrics as well. And we want to make sure that your AI projects are set up for success. So thanks for attending today.
There's a question in the chat.
Oh, great. We'll take that question.
What are some ways to improve recall without significantly sacrificing precision and vice versa? Yeah, that's a very, very good question. Theoretically, precision and recall are a bit counterbalancing each other. So it's really hard to improve precision and not sacrifice recall. One thing I have seen working is if you combine different models which are not as correlated to each other, so they have different sets of predictions, you can find smart thresholds or optimize smart thresholds that when, for instance, one model is wrong, the other one isn't wrong, or vice versa. That is one way you can do this. So playing with thresholds and multiple models is something I have seen working quite well. Another thing is actually precision and recall. It's a single curve, right? So there are points on the curve where just by the dynamics of this model, you just have a slightly better trade-off than any other point. So being fairly aware of the thresholds of your model. But it is a hard question, right? Like, because if you are more precise, your recall will drop. Obviously, a very simple way is just if your model gets better at predicting, right? If the accuracy goes up, your precision recall trade-off gets better. So unfortunately, they're not easy. Otherwise,
otherwise everyone would be doing it.
Yeah, exactly.
there we go. You guys can be the early adopters. So again, thanks everyone so much for joining. And let us know if you've got any follow-up questions. You can reach out to myself at write my email in the chat, Charlotte at Captur AI, and Philip as well. And we will see you at the next webinar. Thanks, everyone.